Analysis of trusses. All right, so a couple of assumptions we make. As I said, well, it's a two-force member, every member in truss. Now, the assumption we make, or something we have to keep in mind, that members of a truss are assumed to be slender. What does the word slender mean? Whenever we use the word slender, means they cannot handle, or that structure cannot, or that rigid body, if it's a slender body, cannot handle lateral load. What does that mean? It means if this is just a member, this member can only handle tension or compression. If there is any lateral force, right, this way, it's axial. These are axial forces, tension or compression. If there is any lateral force this way, a member in a truss cannot handle that, and that's why it's a truss and not a frame or machine. So the general assumption about a truss is that members of a truss are slender and can only support a little bit of lateral loads, and we always pretty much ignore that, in our analysis. They should not be designed to handle lateral loads. Let's put it this way. The main purpose of designing them, they should be designed and arranged, the members should be arranged in a way that they can only be under tension or compression. Right? The cable was only under the compression. Now we can think about a truss member can either be under tension or compression. There are two possibilities for a member of a truss. Let me write it here. The members of a truss can support very little, I would say very little lateral loads. It's always along their axis, the forces. So what do we do? So when we analyze them, we analyze members separately. So we apply the loads on the joint and not the member, because member cannot handle the load, not the members themselves. Let's put it this way. So since it's a two-force member, let me write it here. The two-force member in the truss can either be under tension or compression. As I said, tension, let's write tension or compression. So any single member you take out of the structure of a truss and look at it, it's either, let me try it here. Any member, there's only possibilities. There are only two possibilities. It's either tension, well, this should be along the member. It's either under tension or it's under compression. Think about them like springs. It's either tension or compression. You can't really apply lateral load to a spring. So this is under tension. This is under compression. And that's why it's easier to analyze a truss than a frame or machine, because in a truss, there is one thing established. Every member can either be under tension or compression, and the loads, the resultant load applied at each side of this member, they should eventually be in the same direction. Mainly we just decompose them, find the components in x and y directions. But at the end, when you find the vectors at each end, they should be aligned and they should have the same magnitude, because each member is in equilibrium state. Okay. Sometimes explaining too much things make more confusing. Let's just dive into how can we actually analyze the trusses. Right? The two methods: method of joints and method of sections. We're going to spend this week on method of joints and see how can we use that. And next week we're going to be more focused on method of sections. Now, method of joints is more related to equilibrium of a particle in two-dimensional space. Exactly whatever you learned there, a lot of it you're going to use here. Equilibrium of rigid body, a particle in two-dimensional space. That's the main ingredient of method of joints.